Precipitation is water released from clouds in the form of rain, snow, sleet, or hail. This is how we represent precipitation. The height of the column indicates the amount of rain that falls during a time interval, for example 5 minutes. Sometimes it rains a lot, and in some places it rains a little or does not rain at all. We commonly use millimeters for measuring rainfall. This allows us to obtain the volume or capacity of rain that has fallen. For example, if the height of the water is 1 millimeter and it is distributed on 1 square meter of land, the amount equals 1 litre of water. The same 1 millimeter of rain distributed on 1 square kilometre of land is equal to 1,000 cubic meters of water, or 1 million 1 litre bottles. We use hundreds of millimeters to refer to the amount of rainfall in a region. Imagine how much water that is. However, only a fraction of this water becomes river flow. Moreover, the amount of rainfall is different at a particular site. There are several methods to measure rainfall. One is using a rain gauge. This is a cylindrical container that collects water from rainfall over a period of time. We observe the height of the water at 7 AM and 7 PM each day. So as you can imagine, depending on where the rain gauge is located, manually recording the height twice a day can be very time consuming. Our other option is to use an automatic rain gauge. This automatic rain gauge has a tipping bucket inside with a standard volume. A magnetic sensor registers each time the bucket tips because of the weight of the water. Each tip is recorded in a data logger. From time to time, we can download the rainfall data to a computer, for example once a month. However, within 1 month's time, so much can happen. Sometimes you want to see and use the data more quickly. Where there is a wireless connection or a mobile phone signal, data can be communicated to a central location in real time. But we are not only interested in how much rain falls, but also in how much of this water is available for the ecosystem to function and for people to use. That's why we also measure the water in the river. The water level is measured with a ruler. We also use automatic water level sensors. The most commonly used piece of equipment is called a pressure transducer. The pressure transducer senses small changes in the pressure produced by the weight of both the water and the air that is above it. We use 2 transducers, inside and outside the river. The data logger automatically subtracts the air pressure from the total pressure to get the water pressure. This water pressure is directly related to the depth or level of the water. This can also be achieved by using a vented tube sensor that lets the air enter and directly compensates pressure. The sensor records a measurement every 5 minutes. From time to time, we can download the water level data to a computer. Again, where there is a wireless connection or mobile phone signal, data can be communicated to a central location in real time. But how much water is passing through the river during these 5 minutes? This quantity is the river flow. Flow is the relation between the volume of water and time. It is generally expressed in litres per second or cubic metres per day. To calculate river flow, we construct a structure in the river, for example a weir, that remains unchanged over time. In this way, soil erosion or sediment accumulation does not influence the measurements. We do not commonly measure river flow directly. For a river channel, the river flow can be related to the water level through field calibration. Precipitation and river flow data allow us to better understand how the natural world is acting around us and the best way to use and manage it in a sustainable way. This allows us to make intelligent decisions about the way we live and interact with our environment, especially as we begin to experience changes in our water cycle due to climate change and urbanisation.